course, we have to understand its requirements, we have to understand the changes that are coming and be able to design to adapt to it. Now, let me demonstrate what I'm talking about. See, tea, like all plants, they have an optimum operating temperature. The range for tea crops is between 10 degrees and 30 degrees centigrade. And of course, we require 1,500 to 2,000 millimeter rainfall. Now, while the tree crop can usually tolerate a maximum of about maximum temperature of about 35 degrees, but several days over 35 degrees will lead tea to wilt and fall. And we have seen this happening in much of the world. But long-term exposure, and now temperatures are going above 39 degrees in India, which is a large tea producing country, up in Pakistan, then a long-term exposure over 39 degrees will cause the plant to die. So this could affect the tea industry hugely into the coming future, and we have to be aware of this. And why is this happening? It is because as the temperature increases, chlorophyll, the most important thing we have in our production unit, the green of the leaves, denatures, so that as the temperature increases and it gets heat stress, chlorophyll gets stressed and you get less and less in your leaf production. Now, chlorophyll is an enzyme, and like any enzyme, it has a thermal threshold. As you can see here, the activity goes on, but then there is all kinds of breaking up of the whole system after about 30, and then all kinds of other chemicals appear. If you look at it like this, this is what happens as we move up 25 degrees to 40 degrees, then you start seeing little changes happening. Beyond that, of course, it becomes untenable. So the thermal threshold of chlorophyll, of course, has been first expressed by seedlings. Now, in the area where we grow our tea, or in Myanmar, we grow two crops. Broccoli, you grow very well there. Maize, you grow very well there. But these crops are an indicator of what is going to happen. Because if you look at the growth response of both broccoli or maize, as you increase to 25 or even 35 degrees, 30 degrees, it's collapsing. Broccoli, of course, beyond 20 degrees, no crop. So we must be aware of this. We must be aware that chlorophyll has a rate of reaction as an enzyme. It increases very well until an optimum of 37 degrees. And after that, it begins to crash. And in the whole world now, this is the problem before us, because adaptation is a must with the climate trends, because here are the climate trends through the world. But most worrying for all of us is the countries which are expected to have the most extreme weather fatalities, human beings dying. Myanmar, unfortunately, is the leading country. Myanmar has been identified as being exposed to these extreme weather fatalities. Along with the extreme weather, it's not only human fatalities, it is also our ecosystems and our production systems. And since Myanmar has been identified, we should immediately start thinking about future and future design. Now, how can we cool this heating environment? If everything is getting hotter and hotter, how can we make it cooler? Well, it looks like right in our hands, we have a very useful method, and that is trees and tree crops, vegetational cooling. one tree, we've discussed before, gives you the equivalent cooling of about 1,200,000 British thermal units a day of ambient cooling. Now, for all of you, a good exercise would be, to just take a normal a thermometer, go under into a forest, look at the temperature, go outside, look at the temperature, you'll see the difference. And this is what, if we are clever, we can start using in our design of our new landscapes to enable us to adapt to the coming future. Now, as you can see, the future seems to be not very conducive for industrial agriculture. If you look at this picture, industrial rice production landscape, in this landscape, when the temperature goes up over 38 degrees, 39 degrees, it's uniform all across. There's nothing to break it. There's nothing to move the air currents around. There's nothing to cool it. So you lose your entirety of the crop. Everything fails. If you look at traditional rice in this way, this is in Sri Lanka, where small areas of rice are produced consistently across the landscape, but they're surrounded by trees. It's not a uniform industrial landscape. And these trees and tree crops, as we demonstrated earlier, gives you the cooling factor that in critical days of high temperature could be the difference between having a crop and losing a crop. So designing the new landscapes for the future is really important. Now in tea, let's look at tea. In tea production, we have found that the industrial model, this is industrial tea, a whole hillside, nothing else but tea, no other plants. This model does not provide for soil regeneration or for biodiversity regeneration. This model, the old industrial model, was useful at a time when people are looking at the maximum possible output from a piece of land, not thinking about sustainability. And as a consequence, as we see, sustainability then suffers when you go this direction. Because by not planning for sustainability, tea production becomes unsustainable. If you can see here, there's no protection of the soil, there's no tree plants grown to give mulch, to give any cover, and this tree just erodes. And sadly, when you go into creating new tea fields, then what the industry tells you to do is clear it completely, take every living thing out of it, and then begin planting your tea plants. Usually, the soil is pretty poisoned. So this is not the way to go into the future. And as you can see here, as a clonal monoculture, the tea doesn't put deep roots. And because it has no deep roots, when the soil gets soaked, it falls because there is no feeding of the subsoil by tree roots. Remember, we spoke about that earlier. I'll speak about that again. It's very important to think about that, because here you see a tea field with a little diversity of other plants planted there. And you can see that the soil starts building up immediately and gets deeper. Because as the diversity of plants and the rooting depth increases, so does your living soil. Now, you remember this picture, this is the process of losing the living biomass of any landscape. The biomass is the living biomass, that is the trees above, the plants, and the soil below. The living component is called the living biomass. This is the best, and as it degrades, of course, we know the consequences. Now, we know also that it can be managed. It can be managed by encouraging a living soil to evolve over time. Nature does that by itself, but it takes time. That's where we come in. And we, through our management systems, both organic and aware of soil conservation and soil building, can ensure that we have a very rapid response to soil restoration. And when you do building up the soil, you require a lot of inputs. And the inputs is the compost, where you have a large amount of carbon-based material going in to start buffering and building up the soil microbes. The inputs must include a lot of vegetation material for nutrient production. Now, if the vegetation material is produced along with your tea fields, then it becomes very useful. And if we see that a tea field here, interplanted with different heights of vegetation and a dapple shade, plus a lot of biomass potential, then gives us, a very, very well-balanced tea ecosystem that can help us move into the future. And remember, in a tea ecosystem like this, all the trees, whether coconut, banana, glycidia, all the trees are providing a cooling factor that we discussed, the evaporative cooling. So this field will be kept 2 to 3 degrees cooler than a tea field without these trees in it. Now, the vegetation that we have, a diverse vegetation in a field, not only provides biomass for composting, but it also facilitates the growing of a living soil. Because all trees and tree roots, as we discussed before, provide up to 20% to 30% of the total root weight that they put into the soil to feed the microorganisms that comprise the soil ecosystem. For a tree, it is essential to have a rich living soil around it in order for it to get its moisture and its nutrient for its growth. The microorganisms protect the tree, and in return for all the output that the tree gives, also provides a very, very rich growing medium that the tree can grow in. It is very important for all of us who are involved in agriculture to understand that trees and having deep roots in your agricultural field is critical to ensuring sustainability in your agricultural field. Now, this is because soil itself is a complex living thing. It's an ecosystem where majority of the organisms in the soil have not even been described. It's one of the highest biodiverse ecosystems on the planet. If you consider that 1 gram of good soil, enough to cover your thumbnail, has in it 1 to 2 billion individual bacterial cells. And in this same space, you have 100 to 200 million individual actinomycetes. In this same space, you have over a kilometer length of fungal hyphae. In the same space, there are hundreds and thousands of algal cells, nematodes, collembolism. So soil itself is a living thing, and that is what good farmers have appreciated over time and what modern farmers are beginning to forget. It is the most critical thing that we have to think about when we are building up a good production agro ecosystem. The mass of bacteria alone in the upper 15 centimeters of soil is about 500 to about 1100 kilograms per hectare. This is the energy that organic agriculture provides for sustainable production in crops. Now, we said it's important to have deep-rooted trees in your ecosystem. And that's why when we put in into our forest garden system, when we put in trees into the tea ecosystem, what we are doing is this. The moment we have tree is going in, the rooting depth gets deeper and deeper. And if you look at the soil, you will see it's only the depth that the roots go to that determine how much of soil microorganisms, how many can live. Here you can see the greatest concentration is at the surface, and it's keep going down until the last bit that the root puts out. Beyond that, there is no life. So the living soil is made and maintained by the plants that are above it. And our designs are very important to ensure sustainability in that ecosystem. And when we are looking at restoration of the soil ecosystem, it is most effective when the landscape position is considered. And now we are growing our tea on slopy, hilly areas. When the presentations before demonstrated there are certain areas that are eroding and exposed. Nothing will grow very well there. So we must consider that, because planting here is pointless, whereas planting here is effective. So understand the profile of your landscape and then figure out when and which plants you're going to be utilizing to build up that landscape. Now, here's an example of a forest garden tea that offers different light regimes in an ecosystem. This is kept cool by the canopy. So this tea production here, however high, or not however high, if the temperature goes up by 2, 3, or 4 degrees outside, the tea is still all right and will still be producing. Further, having this kind of ecosystem, this is a forest garden tea, having this kind of ecosystem ensures that these trees will put on deep roots, much deeper than the tea. And these deep roots will anchor the soil and create a living soil in the space, in our tea space that we're growing. So this is how we have to think about adapting ourselves into the future that's coming before us. And if we plant our fields properly and get our fields ready for extreme heat events, we will be successful as farmers into the future. And as we grow in this way, we understand that different light regimes favor different color and flavor characteristics. Tea, our business, relies totally on flavor. So therefore, forest garden tea can be very versatile and can produce a range of products if designed properly. And of course, there then creates a diversity of opportunities for value adding at the community level. Because here in Sri Lanka, for instance, once it was only at an industrial level that people could benefit from marketing tea. But if we have diverse types of tea coming up, then there will be a diversity of opportunities that can be developed at the community level, and the value that we get for our tea will come into our communities. But to do this, the production has to be designed well, has to be monitored well, and if that is so, then we can enter the world market with unique crops that respond and are adapted to the coming future, and crops that take advantage of the new systems that we are hoping to develop. So here we have the value addition to farming systems by certification. Here are the various certification systems. And now that all of you are working with an analog forestry and forest garden products, this is the label for forest garden products. It is a member of the IFOAM family of standards, and therefore it is organic, but it goes beyond organic because it promises the client that the farmer is attending to the biodiversity of the area, to the sustainability area of the area, and is building the resilience of this area to face the coming future. So this is a direction that you could be working in and developing in. I wish you all the very best.